Yeah, because I want to show you some concrete examples to give you better impressions. Yeah. So the second one, the Google search, Google engine, I want to delay. So this second case study, yeah, because today we need to complete that SQL query part, so we cannot use too much time. So I want to delay the second case study sometime later. Okay, yeah, because it's not urgent. Yeah, so we can wait. Yeah, yeah. The first case study, I talk about the Google simulation of Google Map, right? Yeah, simulation of Google Map. One project I did 10-something years ago. Yeah, so that one we almost complete that story. Yeah, but I want to say a little more things first. Yeah. All right. So I think at this point you know the basic idea, right? So this rectangle, we use it to represent the whole Earth. So then we draw grid on it. So the idea is we want to divide it, the large area on Earth, into smaller regions. So very small regions that we can handle quickly. Yeah. Each square on Earth or in this rectangle can be processed quickly. Yeah. So that's the idea. Okay. Yeah. Although the whole Earth, it is very hard to process quickly. If you work on the whole Earth region directly, then it will be too slow. Okay. Yeah. So that's the idea. Yeah. But so I don't want to repeat that idea, but I just want, in order to make this whole story complete, I want to explain some technical problems further. Yeah. So that, because this idea, very easy to understand. Yeah. But you need to make it happen, right? Yeah. So think about, if I assign you this project, so you need to find a way to make it happen. But when you work on it, you need to solve some technical problems. Yeah. Here I just explain one specific technical problem. Yeah. All right. So there is an important step here. I call the registration. Yeah. Or local region registration. So what kind of registration? Yeah. Each block, each square, each block, it's a local region, right? One small local region. Yeah. But the information, yeah. So what kind of derived data we need to generate? We need to generate some kind of derived data. Yeah. The specific derived data we want to generate is for each local region. Yeah. Find all those triangles. Yeah. Remember, so we use triangles to simulate zip code based regions. Okay, zip code based regions. Yeah, to find all those triangles that intersect this square. Right? Yeah. So that's the information we need to do in the pre-processing step. But the question is how, right? How do you do it? So here, you need to think about how do you do it? Yeah. Each local region. Yeah. So you need to, let's say, you need to process these regions in sequence, right? 1, 2, 3, 4. Yeah. So you use nested for loops. Okay. Yeah. From beginning to end, do that processing. Yeah. Yeah. So for each square, you need to find all those rectangles that intersect this square. Okay? Yeah. Now, you think about what is the efficient way to do it. Yeah. So we want some efficient way to do it. We want to find an efficient way to do this. Okay? Yeah. If you do it directly, that may not be efficient, right? Yeah. So if you implement this task directly, okay? Directly. Yeah. For example, so you are working on this particular square. Okay? Yeah. So you take this square, if you compare this square with each of the triangles from beginning to end, then too much work, right? Think about it. Yeah. Too much work. Okay? Because we assume we have 1 million triangles. Yeah. Each of the triangles. So we have 1 million triangles. Do you want to compare the current square, go through each of the 1 million triangles in order to see if they have the intersection? Although you can do it, but not efficient. Too slow. All right? Too slow. Okay. All right. So the better way, the fast way. The better way, the fast way. Okay? All right. Yeah. So here I use S to represent a square. I use T to represent a triangle. Okay? Because we want to determine if a given S intersects with a triangle or not. Okay? All right. So, yeah. So here, what do we want to do? So we have S intersect T equals empty set. Okay, this empty set. If it's empty, no intersection, right? Yeah. So yes or no, all right? Yes or no? Yeah. Yes. No intersection. Okay. No intersection. All right. No intersection. Okay. All right. Yep. That's simple. Right. But if you fix S1, if fix S and go through T, then not efficient. Yeah. Right? Yeah. Because for each S, you need to go through all the T's. Yeah. 1 million T's, right? Yeah. So not efficient. So now we want to do the opposite way. Yeah. Because we know S intersects operation with T equivalent to T intersect with S equivalent, right? Yeah. We just swap S and T, the position. Swap S and T. Okay? Yeah. Then you can see the processing is much easier. That means you fix each T triangle. You fix each triangle. Then you want to see which S. Yeah. Although you want to go through. Yeah. So here you want to go through. Yeah. But actually, you may not really need to go through all the S squares. Yeah. Yeah. All right. First view, you want to go through because very easy. Yeah. Yeah. Because how do I write it? Yeah. Very easy to use X, Y coordinates. Okay. Coordinates to determine those S. Okay? Yeah. Because for a triangle T, we have 3 coordinates, right? Triangle T, 3 vertices, 3 coordinates. Yeah. This one, you can determine which S it is located easily, right? Second vertex, you can determine which S contains this coordinate, contain this vertex easily, right? Third one, also, which S contains that one. You combine with the information from these 3 vertices. Can you determine what are those S, those squares that have intersection with this triangle? Yeah. Yeah. So you can use math formulas. Actually, we can find math formulas. Okay? All right. We can find the math formulas to determine what are those squares that have intersections with this triangle. All right? Yep. In that way, you only need to go through 1 million triangles once. 1 million triangle, go through once. You can find all the intersection information. Okay? Yep. Yeah, but if you do in the first way, you need each square. You need to go through 1 million triangles, and you have a large number of squares. Then you need to multiply that large number. So that's not efficient. For this way, each one, you only need to go through 1 million squares once. Although for each triangle, you need to do some checking, so that work a little more, but just to evaluate some math formulas. Yeah. Not too much work. Yeah. Not too much work. Okay? Yeah. So in that way, so you can quickly get information we need, here, derive the data, that information we need. Yeah. Okay, yeah, so that's the main technical problem you need to solve in order to implement this algorithm. Okay, yeah, all right. Yeah, so here, the reason I explain this kind of details, I want to give you strong impressions. Yeah, because I hope in your future work, when you solve some real world problems, yeah, this idea can help you. Yeah. All right. So that's the case study. All right. The Google search engine, the second case study. So I leave, later sometime. When I have a chance, so then I talk about that. Yeah. All right. So let's continue. Yeah. Next, last slide of part B. Responsibilities for controlled redundancy. Yeah. Controlled redundancy. Who is responsible for this task? Yeah. Manage the controlled redundancy. Yeah. Someone is responsible for maintaining controlled redundancy. Yeah. So let's look at the several different cases. Yeah. The first one, DBMS. Yeah. So I quote this sentence from our textbook. Yeah. So I quote. Okay. All right. DBMS should. Yeah. So I put an emphasis on this should. Yeah. DBMS should have the capability to control this redundancy in order to prohibit inconsistencies among the files. Yeah. But the second half of the sentence, but it couldn't. Okay. It couldn't do it. Too hard to do this for DBMS. Okay? Yeah. The reason is it is too complicated. Yeah. Control the redundancy. This work is too complicated, and the DBMS is not sophisticated enough. Yeah. The current DBMS in the market. Yeah. Yeah. In future, people use AI, probably it's possible, but long way to go. Okay, long way to go. Yeah. So that's why, that's why it says should. When you see should, yeah, you can see the other side. Yeah. It couldn't do it. Yeah. All right. So then what DBMS can do? Relatively easy work. Yeah. Easy things. Yeah. It can do. Yeah. Enforce certain constraints. Yeah. And those certain constraints usually easy constraints. Yeah. In module 3 we will learn those constraints. Yeah. All right. Cannot enforce business rules directly. Yeah. Because usually most of the business rules are very complicated. Yeah, very complicated. Yeah, it's hard to use constraints. Yeah, because the only way, the direct way to represent business, we define different constraints. Yeah, but if it's too complicated, then we cannot use definition of constraints to define the business rules. Yeah. All right. Yeah. Okay, yeah. So then, in order to do that, that's the responsibility of the application programmers. Yeah. The application, you need to write application code to enforce certain complicated constraints. Yeah. But to write application programs, actually the best way is to use store procedure. The best way. Store procedures. This way is better than the store procedure. This way is better than do it in your, how to say that, in your programs. In your programs, yeah. So here, what I said, programs. Let me, example, Java or PHP, application programs. Okay. Yeah, so here I'm talking about. Let me add application program. Application programs. Okay. PHP. Not the SQL programs. Application programs. It's better than that. You store the procedure. Why this was better? So let me explain a little bit. The reason is very simple. If you use stored procedures to implement those complicated business rules, you only need to do it once. Do it once. Okay? So that means more efficient. You only need to write the code once. Then, all other people can call the stored procedure to check those complex business rules. But think about it. If you do it in application programs, Java or PHP, then you may need to do it multiple times. Why? Because it cannot be shared by other programming languages. Think about it. If you implement in Java, then so here the situation I want to give you is in the global, big global web application. Let's assume it's a global. And your application has so many different components work together. All right? And each component could be implemented in different programming language. That's very common. Okay? Due to some reason. Due to some reason. It's not necessary all the components use the same programming language. It's not necessary. Okay? So right now it's very common. For different locations, different services. People use different programming languages to write the code. So then, if you use Java to implement it, then people use PHP, they need to implement their own version, right? And people use C#, they need to implement their own version. So each programming language, they need to write their own version. So that's not efficient. Okay? All right. But if you use stored procedure, the SQL way to implement, you only need to do once. So then all the other programming languages, they can call this stored procedure to check those business rules. So that idea. All right? So then, so we finish part B. All right. Let me jump to part C. Next. All right. Go to part C. All right. Okay. All right. Part C, MySQL regular expressions. All right. The syntax. So it's a very powerful pattern matching language. Okay. Yeah, we do not say language. Yeah, language is too big. Representations, expressions. All right. C.1, database catalog. Yeah, some concepts. I just quickly go through this slide. Yeah, so then we look at the regular expressions. Concept of database catalog. Yeah, so I mentioned that before, right? So when we talk about metadata, yeah, I mentioned this catalog concept. At that time, there is also a name we call a dictionary, right? Yeah, it's also called a dictionary. Yeah. So now let's look at this concept a little more. It contains metadata of the databases. Yeah. So we know the database definition, yeah, and the tables, constraints, domains. When you define those things, it's not business data. So the part you use to describe business data. So that's the metadata. Yeah. All right. So useful information about the data in the database. Yeah. So this data refers to the business data. Okay. Yeah. Business data. And that's our primary data. Yeah. So then information, this metadata part. So here we use this information. Okay. Yeah. And that is the secondary data, or we call it supporting data. Yeah. Yeah. So the content of the metadata: structure, constraints, type, storage format. Yeah. How do you organize your business data? That kind of information. Yeah. Yeah. So you use catalog to store this kind of supporting information. Yeah. And accessed by DBMS. Yeah. Okay. Yeah. So the DBMS knows how to use this information to access the business data. Yeah. All right. And the DBMS catalog, yeah, sometimes people call DBMS catalog, sometimes people call database catalog. Yeah, the same thing. Yeah. All right. A database, right. So here, the inside the DBMS, how to manage the catalog, right? Yeah, because you need to store the catalog information, but in what format the DBMS uses to store the catalog information. Yeah, so this tells you. It is stored the catalog as a database. Yeah, catalog itself, the specific format of the catalog, it is just another database. Okay? Yeah. But this database is a special database. Yeah. This database is a built-in database. It's not created. It's not created by the user. Okay? It is created by the DBMS. So built-in. It's a built-in database. Yeah. This database stores the information of all the database objects. Yeah. These database objects, these created by users. Okay? Yeah. Created by users. Yeah. So that building one, that created by DBMS. Okay? Yeah. So based on this understanding, then you can see, yeah. And in this catalog, this, top You can treat it as a top-level database. Yeah. So this database can be accessed. So we can access that database. Okay. This database. To retrieve information of other databases. Yeah. Actually, in our project number 2, we will do it. Okay. So in our project number 2, yeah, so we will access this top level database to get some information about our working database. Yeah, so we have a working database. But how to extract certain information from our working database, right? Yeah. So there is a way, you can do it. Yeah. All right. So that's the catalog concept. Yeah. So if you understand this catalog concept, then you can see the whole picture better. Yeah. All right. Users are not allowed to modify the detail in the directory. Yes. Yeah. So definitely, because you may messed up, right? So the question, what's the meaning you modify directly? Yeah. Directly, so we know the data stored on the hard drive, right? So if you use some way to access the hard drive data directly, you may mess it up. Yeah. So you're not allowed to do that. Yeah. So you have to access the data through DBMS. Yeah. DBMS gives you the right way to modify the data. Okay? Yeah. Modify the table, you need to use appropriate syntax. Yeah. Things like that. Okay? So not that directly you go to hard drive, you try to work on that part of the data directly. Yeah. Yeah. That's not allowed. Yeah. All right. Users can only view the tables in it. Yeah. 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 Right. I mean, in the catalog, right? Yeah. 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 All right. Only DBMS can access it. Yeah. So that means you need to use the right syntax, right way to access that part of information through DBMS. Yeah. Then another special, NoSQL systems. Yeah. We know that's the non-traditional and for social networking. Okay. Yeah. Specifically for social networking application. Right? Yeah. Do not have the metadata. Yeah. This is an important property for non-traditional data. Why? The reason is very simple. Okay? Why? The reason is very simple. Yeah. Because no need. Okay? No need because too simple, right? The structure of the description of social media data too simple. Yeah. How simple it is? How simple? Remember key value pairs. Okay? The structures, key or You can also call name value pairs. Here, let me use key value pairs. Data format basically in key value pairs. That's the whole structure. Okay. Yeah. So then, no need to provide any description. So that's the reason no metadata. Okay. Yeah. So for NoSQL systems, you don't need metadata. All you have business data. All you have the business data. Yeah. But when you write the programs, so when you do the queries programs, you just based on the internal structure, the data organized in the key value pair structures. All right. Yeah. So that's the first slide. Next, now I need to talk about this regular expressions, the patterns for regular expressions. All right. Yeah. So when we do the SQL queries, after the where clause, so in the where clause, we need to specify conditions, right? Yeah. So in where clause, the question, when you describe your data, because what kind of data you want to retrieve in the where clause, you need to tell the DBMS. All right. So here, there is a specific technique. So let's say it's a technique. So that we can use to describe the patterns of the data. If the data follows certain patterns, then we select the data. So it's a, we need to do the pattern matching. Or we provide a pattern description to our DBMS. So then the DBMS will, based on the syntax of the regular expressions, to extract the data for you. Yeah. So that's the idea. Yeah. But before we go to the regular expression, there is another simple pattern matching way. Yeah. So we can talk about the like operator. Like. Yeah. Like operator, so that's not part of the regular expression. Yeah. It is just a simple operator in SQL that you can use to do the pattern matching. Yeah. But the pattern description for this operator very simple. Yeah. So that's the, the capability is not very strong. Yeah. Yeah. So the pattern matching it can do mainly the simple patterns. Yeah. Complex patterns, we need to use regular expressions. Simple patterns, we can use the like operator. Yeah. All right. So you can see there are two different ways you can use to write your patterns. Yeah. All right. Yeah. But these two ways, yeah, because after you learn these two ways, sometimes some students get confused, messed up between these two patterns. Yeah. Many students, when they use some syntax, yeah. So there, some syntax you can only use in the like operator, but they use in the regular expression. Okay. Some syntax you can only use in regular expression, but they use in the like operator. Things like that. Yeah. Yeah. It's very common. But you cannot do that. So when you use like operator, so you have to use the rules for like operator. Yeah. When you use the regular, you have to use the rules for regular expressions. Yeah. So quite different, completely different. rules. Yeah. All right. Yeah. Yeah, we will see that. Yeah. Yeah, because the like, yeah, so here what I'm doing is the regular expression. Yeah. But here, because regular like operator is so simple, yeah, so let me just quickly say something like operator. There is a, you know, percent sign, special character, okay? So when you, yeah, the percent sign you can use to represent, you know, anything in this like operator. All right. So for example, you want to match. Yeah. So I need to give you an example. Okay. Yeah. You want to match a pattern, the pattern description here. Use a string to describe pattern. Okay. Percent ABC. Suppose this is the pattern. Yeah. That means you need to, the data you select should match, you know, the last three character must be ABC. Before ABC, anything. Okay, this percent represent anything. Okay, all right. If the ABC is in the middle, yeah, so you need the left percent after ABC, you know, right. Yeah. Because after ABC, anything is fine. Yeah, including empty string, nothing also can be matched by that percent sign. Yeah. Yeah, things like that. Yeah. So this is the main pattern was used. Yeah. So there are some, you know, other small syntax. Yeah. So we can see later. Yeah. All right, so that's the like operator. Yeah. Then let us look at the regular expression. The rules. So this slide, the rules. Then next a few slides, I give you examples to apply these rules. All right, the pattern and to be matched. Yeah. The rules. Yeah. So one is pattern, yeah. Then rules. Yeah. First, this pattern. Okay, this sign. Yeah. You know, yeah. This kind of, yeah. Beginning of string. This symbol represents beginning of the symbol. Yeah. So you want to describe some pattern at the beginning of the symbol. You need to start with this, you know, wedge sign. Yeah. All right. Yeah. Or hat. Yeah. Like a hat. You know. Yeah. Whatever. Yeah. Then the dollar sign, the end of the string. Yeah. If you want to describe certain pattern that appears at the end of the string, then you need to append this dollar sign. Yeah. That's simple. Yeah. Dot. Yeah. One dot has a special meaning. Any single character. One dot represents any single character. Yeah. That's special meaning in regular expression. Okay? If not in regular expression, then you don't have this meaning. Okay? Yeah, you don't have that meaning. Yeah. All right. Yeah, because in like operator, so then that single character, you use question mark. Okay? You use question mark as the single character. So that's why, you know, do not get confused. Yeah. Question mark. Yeah. Then star, yeah, 0 or more instances of preceding element, yeah, preceding pattern. Yeah. Element here means you use a small pattern substring. Yeah. Because what's the element? Yeah. You use a substring to describe a pattern. Yeah. So that part that we call it the element, one element. Yeah. One special pattern portion, yeah, and you want to repeat that instance multiple 0 or more times. Yeah. 0 or more times. 0, yeah, you do not use that. Then 1 or more, yeah. So that's the star. Yeah. plus one or more. One or more instances of preceding element. Then a pair of brackets inside, a pair of brackets around certain pattern descriptions. Around. That's the any character listed between the brackets are options. Are options that can be used. For example, so if we use bracket ABC to describe one element, okay, one particular portion of the pattern, so that means you can choose either three options you can use for this particular character, A or B or C. So here, A, B, C. But if you have many characters, then you don't want to list all of them. Too long, right? A dash P, for example. Okay? Then, all the characters between A and P all included. Digit, digit you can use that way. Bracket 0-9, all the digits. In that way, okay? Then this one, so this, little hat symbol inside a pair of brackets, then its meaning is different from that, okay? So here you need to be careful. These two meanings, different, okay? Different. Do not get confused. The meaning inside the brackets, that's not operator, okay? Any character not listed between the brackets. It's like a negation operator. Negation, okay? Not ABC, right? For example, not ABC. If I do this ABC, then characters other than ABC could be used in this place. Not. Then vertical bars, P1, pattern 1, vertical bar, P2, vertical bar, P3. That's all, okay? So you can use either P1, P2, or P3. One of the three patterns. Use vertical bar to separate, okay? All right. Alternation matches any of the patterns. Matches P1, it's okay. Matches P2, it's okay. Matches P3, it's okay. So vertical bar. Because usually for the cases like this, P1 could be a relatively complex pattern. Then you use vertical bar to separate. P2, another relatively complex pattern. After that, you use another vertical bar to separate. And then P3. If the pattern is simple, you do not need a vertical bar, right? For example, this ABC. ABC, too simple. Although, if you use vertical bar to separate it, it's legal. The same thing, But you don't need, right? So that's usually because your P1, P2, you may need multiple characters, multiple symbols to represent. Then you need to separate. Otherwise, you don't know the boundary, right? You don't know the boundary between two different patterns. So we use the vertical bar as the boundary symbol. All right. Next one. A pair of curly braces around a number. This n means a particular number. Okay. What do you see? It's not this little n. So this is a certain number. 5, 10, 4. It's a particular number. It's not really the n's. So n instance of preceding element. Preceding, so there is a small subpattern, but you want to repeat it n times. So n instances of the preceding element. Then another similar, you have curly braces around two integers, m comma n. M comma n. That means the instances from m through n instances. The minimum number of instances is m, the maximum number of instances n, then including all the numbers between these two numbers. Yeah. So okay. All right. So that's the basic patterns we need to learn for this class. Yeah. Although for regular expressions, there are a large number of pattern description rules. Yeah. But I think if you need to use regular expressions in your real world situations, you just search the documents, online information examples. Yeah. But here, mainly give you basic ideas. Yeah. All right, how to use regular expressions. C.3, examples of regular expressions. Yeah. So let me just give you several examples using the rules from the previous slide, to give you some ideas. All right. The first question, so when we talk about the question, so for this part, we need to use a database I mentioned before, but this time we really need to use it. Yeah. So I will post the company database. The company database. I will upload after class. Yeah, so you download, so you can install on your machine. Yeah, so you can practice. Yeah. Question: retrieve all employees whose addresses. Address as a string. So this string we use some pattern to describe. In Houston, Texas. Houston, so that information, how to represent that information in your pattern. It's very simple. Houston, Texas. All right, there. So we only focus on the where part. Yeah, so because here, this one's so simple. So the first method we use like operator. Yeah, before Houston, anything is fine. Yeah. After TX, anything is okay. Okay? Yeah. For the address. Yeah. All right. So that's the like operator way. Okay? Yeah. So usually for the simple patterns, so you consider use the like operator. Okay? Yeah, using the like operator. Yeah. If it's too complicated, then you use the regular expressions. But this one, we want to practice. So we also want to see how to use regular expressions to represent this pattern. All right. Regular expression version, now you can see anything before Houston is okay, then you do not need to put anything, right? Yeah. If you do not put anything, that means anything before this pattern can be matched. Yeah. You don't need to describe it. Okay? Yeah. So here you can see the philosophy or the approach used in different from that like operator. Yeah. 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 So you do not put a restriction that here, when you do not put a restriction, that means you allow it, right? So the logic in regular expression. So there is no restriction here. Then you allow it. Okay? That philosophy, okay? That logic in regular expressions. Then after TX, you do not use any restriction there. So then anything after TX can be matched. Yeah. So that's the, try to feel about it. It's different from the like operator. Like operator just opposite, right? So if you, for example, if you drop this % sign, you use Houston remaining, then nothing. You can put nothing here, okay? Yeah. Nothing before Houston, okay? You have to start with Houston, right? Nothing before Houston can be matched. Yeah. So you can see it's quite different. Yeah. The logic is quite different. Yeah. All right. But another little subtle thing, yeah, another little thing you also need to consider, because when people write address Houston, comma, Texas, the question is there a space character between comma and the TX? Think about that. Yeah. Sometimes people may like to put a space, but sometimes people may not put a space, right? Yeah. So think about in the real world situation. Yeah. The question, do you allow both ways? Yeah. So you may allow both ways, right? Yeah. For the data entry part, you don't want to reject that one, right? Yeah. So if you allow both ways, then you need to represent both ways. You need to find a pattern description covering both ways, yeah, including the space, without space, with space. Both ways should be covered in your pattern, right? Yeah. Then, in this situation, you can see the like operator is not good enough for this purpose. The like operator. It's hard to represent this way, right? A space, character, or no space character. In this case, we need to use the regular expression to do it. Yeah. All right, the missing space character. How to do it? Yeah, use our curly braces. How about that? Before curly braces, there is a space operator. Yeah. Then inside curly braces, M and N, right? M comma N. 0 means no space, right? The previous element, the preceding element, repeats 0 times. That's no space, right? Then up to at the most 1, yeah. So then 1 space, then 1, yeah. See? So for this regular expression, you can easily represent that, little subtle requirement, yeah, in this way. Okay. All right. Yeah. Yeah. All right. Some more examples. Yeah. Next example: retrieve all employees whose address is in California, and the street number has exact 3 digits. Yeah. Street number. Yeah. Street number. Yeah. Yeah. All right. So the state information usually at the end of the address, right? Yeah. If we consider if the data has that property, then the street number usually appears at the beginning of the address, right? Yeah. If we understand in that way, here you can see we need to use the regular expression. Yeah. We cannot use the like operator. Yeah. Like operator, because it's too complicated. How do we represent exact 3 digits in like operator, right? Yeah, it's too hard. Yeah. All right. Yeah. And we also need, because here we have 2 properties we need to represent. Yeah. So this and we need to consider. Yeah. All right. Yeah. Yeah. So look at the beginning, the street number appears at the beginning of the address. This symbol, that's the beginning of the string. Yeah. Then the digits. So we need to describe. Each character is one of the 10 digits, 0-9. Yeah. But we need to, that digits repeat exact 3 times. 3 times. Okay. After 3 times, there is a space to stop it. Stop that string number. Otherwise, you won't get exact 3 digits. Okay. Yeah. So you have to use that space character to stop the string number representation. Yeah, only 3 digits. Yeah, no more than that. So then after the space character, dot means arbitrary character. Yeah, anything, 1 character, dot. Then the dot repeat 0 or more, right? The star means 0 or more. Then CA, the state representation, then end of the string. So this end of the string. Yeah. So in this way, you can write it. Okay? Yeah.
In this example, would we want to have it possibly read zip codes too, or not?
Sorry, what code? Zip code or pass?
Zip codes after the state?
Oh, after, oh yeah, oh, okay, good question. Yeah, all right. Yeah, good question. If zip code thing, yes, then not $sign, okay? We remove $sign. Yeah, good. Yeah, you're right. Yeah. So if we, so we need to consider the zip code. Yeah, good. Yeah. So then remove that $sign. Yeah, good question. Yeah. So here, I just talk about some the capability. Yeah, but the real data, so it is slightly different, different from what I talk about. Yeah. Good. All right, let me look at the time. 5 minutes left. Yeah. All right. So, yeah. All right. Yeah. Right. Do not use the percent sign because some students get confused. Okay. Some students just borrow the meaning from the like operator. So they get confused. So they put percent sign there. Okay. When I did the grading, I noticed that problem frequently. Yeah. Just be careful. Yeah. The syntax problem. Yeah. All right. Retrieve all employees whose first name starts with A, B, or C. Yeah. That's simple. The first name. Yeah. All right. So first you get a first name starts. Yeah. Starts. So that's why you need to use, that notation. Yeah. But actually, vertical bar is not necessary, right? Yeah. Because if you use, actually even use parentheses, still okay. Yeah. So many different ways, or bracket around no vertical bars. Yeah, because ABC is so simple. Why we need a vertical bars to separate, right? So we don't need a vertical bar to separate ABC. Yeah. So usually for some multiple symbol patterns. Yeah. So we need to use a vertical bar to separate. Single character pattern. So we don't need a vertical bar to separate. Yeah. All right. Yeah. So that so many different ways. Yeah. All right. Then I think the last slide I want to talk. Only have 3 minutes left. Yeah. Let me see one more example. Let's just do one more example. So then we finish today. Last question. Retrieve all employees whose last name has exactly 6 characters. Yeah. Another pattern. Exactly 6 characters. Okay. Yeah. So let's represent that regular expression. Yeah. So here, beginning and 1 character repeat 6 times. Yeah. Any character you can use, but that that single character should be repeated exactly 6 times. Yeah. That description. Okay. Yeah. The simple way. Yeah. But there is another simple way I like to introduce. Yeah. So we use a special function, a length function. There is a function called a length function. Yeah. So in this situation, because the length of the last name is 6, we use that way. That's not regular expression. That's the length function. Yeah. So you can use, length. That's the function name. Length of last L name equals 6. Yeah. So length function supported in MySQL. Yeah. It may not be supported in other programming let's not program other versions of SQL in other DBMSs. Yeah, but yeah, so that length function, yeah, it's a simple way. Yeah. All right. Yeah. So let me stop right here. Although I have a few more examples. Yeah, but I think you get the main ideas. Yeah, at this point. Yeah. Then the remaining character we will do next time. Okay, we will complete next time. Yeah. All right. Yeah. So let me stop right here.